Dear students, this is a continuation of our previous video lectures. We are solving problems on the topic theorems under Laplace transform. Here the question is, find the Laplace transform of t e to the power negative at. We observe that we have to find the Laplace transform of product of two functions. So whenever we have product of functions, we have to use the theorems under Laplace transform. And we see that here one of the function is t and the other function is e to the power negative at. In order to find the solution of this problem, we can either use the first shifting theorem or the second theorem from Laplace transform. According to the first shifting theorem, we know that the Laplace transform of e to the power negative at f of t is equal to, we have to find the Laplace transform of f of t and we have to replace s with s plus a in the solution. So we can either use this or we can use theorem 2 where we have to find the Laplace transform of t f of t and that will be equal to negative d by ds of Laplace transform of f of t. We can use any one of this theorem in order to find the solution of the given question. I would always suggest that if you use the first shifting theorem, it will be more convenient than using the second theorem to find the solution of the given problem. So we will use this method, that is the first shifting theorem, and find the solution. So in that case, we will rewrite this question. So Laplace transform of t e to the power negative at, we will rewrite in this format, for which we have to write it as Laplace transform of e to the power negative at multiplied with t. Now the function f of t over here is t. So we have to find the Laplace transform of f of t first. So what is f of t? T. So Laplace transform of t, and at the place of s in the solution, we have to replace it by s plus a. So this is the concept that we are going to use. So here, because we have negative a, we should replace it by s plus a. You will understand this concept if you go through the problems under the first shifting theorem. So we will proceed further. Laplace transform of t. What is this? So by the results we know that Laplace transform of t is equal to 1 by s square. The Laplace transform of t is equal to 1 by s square. This is because we have used the formula Laplace transform of t to the power n is equal to n factorial by s to the power n plus 1. So when we use this, at the place of n we have 1 over here, and so we will be having 1 factorial by s to the power 1 plus 1. So it will be s square. So 1 divided by s square. So let us substitute that over here. So we have Laplace transform of t to be equal to 1 by s square. So 1 by s square, and at the place of s over here we have to replace it by s plus a. So therefore it will be equal to, so after replacement we may remove this curly brackets and the solution will be, instead of s we have to replace it by s plus a. So s plus a the whole square. So this is the required solution. So the next problem is problem number 24, which says that to find Laplace transform of t e to the power negative phi t. So we can rewrite this question as Laplace transform of e to the power negative phi t multiplied with t in order to use the first shifting theorem. So what does the first shifting theorem say? We know that the Laplace transform of e to the power negative at f of t is equal to Laplace transform of f of t, where in the solution we have to replace s by, because we have e to the power negative a, it has to be replaced by s plus a. So this is the first shifting theorem. So applying this theorem to our question, here we have Laplace transform of e to the power negative phi t, f of t is given as t over here. So this will be equal to Laplace transform of f of t. What is f of t? It is t. So Laplace transform of t where s has to be replaced by s plus a. What is a over here? It is 5. The value of a is 5 over here. So it has to be replaced by s plus 5. And so this will be equal to, what is Laplace transform of t? It is 1 by s square. And in this solution we have to replace s by s plus 5. And so therefore the final answer will be 1 by, so instead of s we have to write it as s plus 5 the whole square. So this is the solution. We shall now do problem 25. So the question here is, find Laplace transform of t square e to the power negative 3t. Now this here we have the product of two functions, where one of the function is t square and the other function is e to the power negative 3t. So we can use the first shifting theorem. So we know that according to the first shifting theorem, Laplace transform of e to the power negative at f of t is equal to Laplace transform of f of t, where in the solution we have to replace s by s plus a. Because we have negative a here, we have to replace it by s plus a. So applying this theorem to our given question, we shall rewrite this. We will write it as e power negative 3t, and at the place of f of t, we have t square over here. And so that will be equal to Laplace transform of f of t. What is f of t? It is t square. So Laplace transform of t square, where in the solution we have to replace s by s plus a. And so that is equal to, what is Laplace transform of t square? We know that the Laplace transform of t to the power n is equal to n factorial divided by s to the power n plus 1. So now we are going to apply this result over here. At the place of n, we have 2. So it will be 2 factorial. But 2 factorial is 2 only. 2 factorial divided by s to the power 2 plus 1, which is 3. And here we have to replace s by s plus a. But what is the value of a over here? It is 3. So we have to replace by s as s plus 3. And so the solution will be equal to 2 divided by s plus 3 the whole cube. So this is the solution. And now we have problem 26, which is find Laplace transform of t square e to the power 3t. So we know that we have to use the first shifting theorem. So we are using it over here. And because we have e to the power 3t, we are using e to the power 8t in the first shifting theorem. And the answer is 2 by s minus 3 the whole cube. In a similar way, we have problem number 27, which I have already solved for you. So here problem number 27 is, find Laplace transform of t cube e to the power 2t. So when we apply the first shifting theorem, we get Laplace transform of t cube, where s has to be replaced by s minus 2, because we have e to the power plus 2 over here. So what is Laplace transform of t cube? It is 3 factorial divided by s to the power 4, because Laplace transform of t to the power n is n factorial divided by s to the power n plus 1. So here the value of n is 3, and so we have 3 factorial by s to the power 4. And in this solution we have to replace s by s minus 2. So therefore replacing s by s minus 2, we get the answer to be 6 divided by 6, because 3 factorial is 3 into 2 into 1, which is 6. So 6 divided by s minus 2 the whole to the power 4. So this is the solution. Hope you have understood all the 5 problems that we have dealt in this video. In our next video, we will be learning how to find the Laplace transform of product of 3 functions. So when we have the product of 3 functions, how we have to find the Laplace transform is what we are going to learn in our next video lecture. So kindly follow the lecture. Thank you.